Hello and welcome back to the channel. In today's video, we're going to be looking at how we can use the turning point form and factorization to solve for the roots of a quadratic. Let's begin. Using the turning point form and factorization, we will have to solve a little bit. So why don't we do that now? So let's take the value that we produced using the turning point form. So x plus 7 on 2 squared minus 25 on 4. So y equals that. So we studied in the quadratics video and the graphing video that to find the roots, the points where the graph crosses the x-axis, we need to make y 0. So the reason is because at this line here, where the x-axis is, y is going to be 0. So then we can solve this quite easily by assuming then that y, by substituting 0 into y. So 0 equals x plus 7 on 2 squared minus 25 on 4. And now what we need to do is solve. So we plus 25 on 4 and plus 25 on 4. So minus 25 on 4 plus 25 on 4 equals 0. And then we get plus 25 on 4 on this side. So 25 on 4 equals x plus 7 on 2 squared. Now, what we need to do is remove the square root by square rooting both sides. So square root x plus 7 on 2 squared and square root 25 on 4. So let's take this to the next page. There we go. So if you remember from your study of number theory and fractions, the square root 25 on 4 is equal to the square root of 25 on the square root of 4. That's equal to x plus 7 on 2 squared, which is equal to, no longer need the square, because here the square and the square root were cancelled out. So we're left with x plus 7 on 2. Now, this number is quite nice because the square root of 25 is 5, and the square root of 4 is 2. So we get 5 on 2 is equal to x plus 7 on 2. Now, we minus 7 on 2 and minus 7 on 2 here, and we get minus 2 on 2 is equal to x. So, what does this mean? This means that x equals minus 1. But there is another value. So if we go up here, this square root function can have both a plus and a minus attached to it. So yes, one of the values is going to be minus 1, but the other value is going to be minus 5 on 2. So if we draw that out over here, minus 5 on 2 equals x plus 7 on 2. Now, why minus 5, you might ask? Well, two negative numbers, when multiplied together, produces a positive number. So 25 can be written as both 5 times 5 and negative 5 times negative 5. Therefore, the square root of 25 is going to have 2 values to it. Now, the square root of 4 is also going to have 2 values for it, plus and minus. But those are cancelled out because plus and minus are going to be exactly the same. So we're only left with 2 unique solutions. So plus and minus. So all you need to think about is whenever we square root a fraction, we can either have the fraction as positive or we can have the fraction as negative. So we need to solve now for the negative fraction. So minus 5 on 2, minus 7 on 2 is going to give us minus 6 equals x. So we have 2 results for the roots. Now, why are there 2 and not 1? Well, if you think about a quadratic, they cross the x-axis at 2 points. So they're going to have 2 roots. So this is going to have a root at minus 1 and at minus 6. So these are the 2 roots of our function. Now there is another way to solve this. So if we go back to how we factorized, to when we factorized, and we take the result we produced, so x plus 6 and x plus 1, for the same answer, we get y equals, let's just erase this, y equals x plus 6, x plus 1. Now, as we did for the last one, we make y equal to 0 because y equals 0 at the x-axis. So 0 equals x plus 6, x plus 1. Now, we get a 0 whenever a number, so x times 0, will always equal x. So x plus 1 times 0 is also going to equal 0. So that means that either x plus 6 equals 0, see that equals 0, or x plus 1 equals 0. Now, what value of x will make x plus 6 0? Now that is going to be minus 6. So plus 6 minus 6 is going to make this 0. The same happens for this side. So minus 1 plus 1 is going to equal 0. So our two values are going to be minus 1 and minus 6. Now, these are exactly the same values we got by using the turning point formula. So both are equally valid. Now, this mechanism, the factorizing mechanism, is faster, but it does require you to recognize these numbers without doing any maths, while this is going to work every time because it uses algebra. So up to you which you use, and of course the quadratic formula is always an option to help you calculate the roots every time using a, b, and c from the equation ax squared plus bx plus c. Now this is the quadratic formula, the quadratic standard form. if you want to learn more about it, please go see the quadratic video. So I hope this has been helpful. In the next video, I'm going to be taking a quick dive into common factors that we might see. In this video, we had a look at factorizing. We looked at how we can use the difference of two squares to factorize, how we can use normal factorization, recognizing the addition and multiplication of the roots, and how we can use the quadratic formula to solve for the roots. We then solve for the roots by making y equal to 0, and we then tried that using factorizing as well. On top of that, we had a look at how we can use two bracket equations, so a plus b and a plus c, and expand and factorize that to make a quadratic or to factorize a quadratic. I hope this has been helpful. Please subscribe and like if it has. Go to answerme.com to vote for next week's topic. And I'll see you all in the next video. See you then.